Greetings, M Squared here, and today we're going to solve some more literal equations. These ones, you're going to notice that the letter I'm trying to get alone happens more than once. So we're going to use something called factoring to get that. You can't combine dA and FA. They're not like terms. But we can factor out an A. It's kind of the opposite of distributive property. So if you saw an A in both of these things, you would have known that A would have had to gone out here, right, in front. If you had distributed A, this is what you'd get. So it's called factoring the greatest common factor out. When I notice it twice, and I can't combine like terms, so I decide to factor it out. And notice D times A gets me my dA. A times F gets me my FA. Always double check to make sure you got it right. But we notice a common factor and we factor it out. All right, so now that we've done that, our goal is to get A alone. We're going to divide by whatever's being multiplied. So we're going to divide by D plus F. Again, watch your capitals. Okay, watch your capitals. If it's capital, keep it capital. If it's lowercase, keep it lowercase. So my A is equal to B over D plus F. And remember in delta math, if you need to make that fraction bar, you're going to use your slash. If you need to make an exponent, you're going to use that caret. And then whatever comes next is going to be your exponent, and that's above the 6. And this is by the question mark. All right, so that was our answer on that one. And here we go. We need to solve for B, and there's two B's, so I'm going to factor out a B. And when I do that, I say what times B equals GB, what times B equals NB, and that would be G and N. And then I need to divide by whatever is being multiplied by B, which is G plus N. So I divide by G plus N. Those get me a 1, and 1 times B is just B. And I'm left with 2F squared over G plus N. All right, hope you're getting this factoring thing down. Those are a couple examples. Now we're going to switch. So now it's a little bit different. We are trying to get F alone, but there's more than one thing happening. So we have H that's being added to an expression with F, and 5n cubed is being divided by just the F. Whenever that happens, whenever we have something added or subtracted from the term that has the variable that we're getting alone, we always want to get rid of this guy first. As otherwise, if we multiplied both sides by 5n cubed, you'd have to do it here, here, and here, and then it just gets a little more complicated. You can do it, but it's a little easier to get rid of this first. So we're going to do that first. We're going to subtract h from both sides. So we still have our f over 5n cubed, and now we have g minus h. And now, this is the only thing preventing us from getting f alone. It's being divided, f divided by this, so to get rid of it, the opposite of division is multiplication. Notice I'm multiplying the whole side by 5n cubed. So then my answer, because those cancel out, get a 1. 1 times f is f. I can put it, most people like it in front better, but it wouldn't matter as long as you had those parentheses in it. You could put it on the outside. It's still acceptable. All right, last example for today. Again, we're trying to get D alone, so we need to get rid of this thing that's being added or subtracted first. So I'm going to subtract n on both sides, and I get dm cubed equals r minus n. And now m cubed is being times by d, so we have to do the opposite and divide. And then it cancels because m cubed divided by m cubed is 1, and 1 times d is d. And I get r minus n equals m cubed. All right, so that was a little bit of factoring and a little bit of, multi-step going on. So good luck with that. M Squared, signing out.